So welcome to part 5 of this tutorial series on Python from WiseOwl Training. In this tutorial, what we're going to do is learn about modules. What we'll cover is this. We'll start by looking at built-in modules using the example of calculating the square root of 2 with the math module. And then we're going to look at how you can import modules. We'll look at examples of built-in modules. So we'll look at things like OS and SYS. And then we'll look at the all-important topic of installing external modules using the example of requests to get information from public websites. We'll then go on to look at the ModuleNotFoundError, which had me tearing my hair out when I was teaching myself Python. And finally, we'll look at viewing modules and listing them. At the top right of your screen, round about now, you'll see a little icon appearing, and you can click on that at any time to see any files to do with this tutorial or any exercises. But I think that's enough of me, so what I'm going to do now is to hand over control to my capable assistant Sven, who'll guide you through the rest of this tutorial. So let's get started. What we're going to do then is to calculate the square root of 2. That doesn't sound that ambitious, does it? And perhaps it isn't, but it will allow me to show about built-in modules. To do that, I can go to the Explorer tab, the top icon in the activity bar. I can choose to add a file into my tutorial folder or anywhere else for that matter. And I'm going to call it built-in modules for reasons which will become apparent, I hope. Don't forget the .py at the end of it. So what I'll then do is put a comment in saying that I'm calculating the square root of 2. So to do this, I can just print out the square root of 2. Unfortunately, there's a function in Python built in called sqrt. Although that doesn't actually seem to be true, because when I type it in, it doesn't recognize it. And the reason it doesn't recognize it is because it's in a separate module. A module is basically a library of different functions that you can access, and they are the heart and soul of Python. So the module I'm looking for is actually called the math module. And what I'm going to do is show you 3 different ways in which I can import that so that I can access its functions. The first way is just to type it in like this, import math. And it's a good sign that it appears in the IntelliSense. That suggests it actually does exist. Then, when I want to use one of its functions, what I can do is type in the name of the module, math, and then put a dot in. And you can see I've then got access to all of the functions it contains. And remarkably, Visual Studio Code has remembered that I typed in sqrt and has guessed that that's the one I want to use. But you can see there's just about every mathematical function I could ever want to use there. So I'll type sqrt, I'll put open brackets, 2, close brackets, and I'm in a position now to run my code. So when I press Alt-Control-N in Code Runner to run my program, I get 1.414. So that's one of 3 ways to import a module. What I'm going to do now is to select those 2 lines of code and just comment them out so we can refer back to them, Control/. And then what I'll do is show you the second way to do this. I'll just get rid of my terminal window. Not like that though, like that. So the second way to do it is to import not the whole module, but just the function I want. So what I can do is put from the module called math, import just the sqrt function. And the only real advantage to this is when you're processing your program, it should run slightly more quickly, because instead of having to import all of the code in the math module, it just has to load up a single function. So what I can then do is repeat my previous command. I can say print, and again I'll say math.square-root. But this time, when I type math.square-root, it doesn't recognize it, and that's because I've chosen just to import the function. So now I have to miss out the name of the module, and I can just put square root of 2, which makes it easier to read too. So when I run that, I get the square root of 2 again. So that's my second way. My third way is to not only just import the function I want, but also to give it an alias, another name. So to do this, I can say from my module called math, import my square root function, but also give it an alias. I'm going to call it square root, which I think is probably a slightly better name, if longer. And what this means is when I come to print out my answer, I can type square root or sqrt, and then put brackets 2. And when I run that, it will give me, yet again, the square root of 2. So those are the 3 ways in which you can import modules or just specific functions. The next question is, what on earth built-in modules are there, and how do you find out what's available? And we'll look at that next. So we've seen one built-in module in Python. What are the others? Let's have a look, shall we? Let's see all the built-in modules. You can go to this link, which I've included in a text file attached to this video, to see a list of all the built-in modules in Python. And it's quite an intimidating list because there's so many of them. I would say I don't know what 1 in 5 of these do. So which are the important ones? Inevitably, it's a bit subjective, but I would say these probably. So let's have a quick look down the list. If you're working with maths, you can use CMath for working with complex numbers. You can use math for working with normal functions. You can use statistics for working with statistical functions, fractions for working with fractions, and you might find random useful for working with random numbers. If you're working with files, you can use CSV to load CSV files, and you can use JSON to work with JSON files. If you're working with dates and times, you can use datetime and time. If you're working with things to do with an operating system or anything to do with files or folders, you'll probably find OS and sys useful, and we're actually going to look at those 2 in a second. And then there's a few specific ones. Email for sending and receiving email. Enum is something which you'll either know about or you don't. If you're an existing programmer, you'll have worked with enumerations possibly, and this is how to do them in Python. gzip for compressing and uncompressing files. RE for working with something called regular expressions, which again is something which you'll either be familiar with or not. And tkinter if you want to build your own graphical user interface system. So those are, I think, the most important built-in modules, although I'm sure people will disagree with my verdict. Let's have a look at a couple of specific examples now. So I said we'd do a couple of examples. Let's actually do 3 quick examples of using built-in modules. So I'm going to insert a new file. I've created a new folder called O5 modules while you weren't looking, I'm afraid, to tidy up my work. And I'm going to call this new file examples of built-in .py. So the first thing I'm going to do is print today's date, which might seem an unambitious task again. All of the date functions in Python are hidden away in the datetime module, so I need to import that. But actually, that module itself contains a datetime function, and it's that I'm going to bring in. So I'm going to say from the datetime module, I'm going to import datetime, and I'm going to give it an alias. I'm going to call it datythings, which is the least professional name I could think of at that time. So now I've imported that, I could show today's date. So I could print out, and when I type datythings and put a dot at the end of it, you can see it comes up with loads of built-in functions to do with dates and times. I'm going to choose today. Now, one of the things you may struggle with in Python is whether you're using a function or not. If I try running that as it stands, you'll see it gives me this error message, or maybe not an error message. It says it's a built-in method. That means I missed out the open and close brackets because this is a function and not just a property. So I'll just show you how to correct this there. That will give me today's date and the time as well. That's when I'm writing it. Welcome to the 12th of October. So a couple of ways to seeing whether you're using a method or not. One way is when you type it in, you can see there's 2 different symbols you can get. One of them is this sort of cubey symbol, and that means you're using a method. And the other one is also a cubey symbol, but in a different color, which is meant to signify a property. But there's possibly an even easier way, which is when I type in a method or a property in Python, when I let my mouse linger over it, it will come up and either say function or method there if I'm expected to put brackets after it. If it doesn't say method and doesn't say function, you can safely omit the brackets. So this is a method or function, so I need to put open and close brackets after it and then close my print brackets. So that was my first example, with a bit of a digression. What we're now going to do is to show the version of your operating system, or sorry, the name of your operating system, which is probably something you know, but will be useful for testing out whether you're using Linux or Windows, for example, when you're running code on someone's machine. So I'll show the operating system name. So to do this, I can import the OS module. I won't bother giving it an alias. And what I can do, for example, is print out the name of the operating system. And following on from what I was saying earlier, you can see that this has this symbol to the left of it, so it's a property. And when I type it in and let my mouse linger over it, which I'll just do now, you can see it doesn't say method or function there, it says variable. So I'm good at missing out the open and close brackets after it. And if I run that, you can see it gives me NT. Not quite what I was expecting. I thought I was using Windows 10, but that must be the internal name. You may have a Linux if you're running this on Linux. One other thing I could do in the OS module is, for example, I could print out the current folder, and I need to put the open close brackets because this is a function. So if I run that, it will give me my current folder in which I'm working. So my third example is going to be how to get the version of Python I'm using. So to do this, I will use or import the very useful sys module. And sys gives you access to all sorts of internal things to do with your environment. So what I can do is print out, for example, sys.version, if I could spell. Again, I can let my mouse linger over that, and it tells me it's not a method or a function. And so I don't need to put open and close brackets, it's just a property. And I run that again, you'll see it gives me the version I'm using 3.9.7 with a great deal of other information, which I'm sure is terribly interesting. So that's some examples of built-in modules. I think it's probably time now to have a look at how you can install external modules. So what we're going to do is show now how to install external modules. And the example I'm going to use is a new file, which I'll call installingmodules.py, which will try to get the HTML from a website. So go to a website and return results. And to do this, I'm going to import the requests module. The request module really clearly does exist because it's coming up in the list. But when I press return, you can see it's underlined it. And if I try running that by pressing Alt-Control-N, you can see ModuleNotFoundError. This is quite a persistent error, as we'll see in the next part of this tutorial. But for the moment, the reason is quite simple. It's I haven't installed this as a separate module. You can see this because if I look in my library, you can see my side packages don't include the request module. So what I need to do is I need to add that in. To do that, I can go to the terminal window and I can type in Python, because I'm running a Python command, -m, as previously discussed, pip, which is a utility, it's shown there on the left-hand side, which allows me to install modules and get around much of the complexity of installing Python modules. Then I need to put install with 2 L's, and then I need to put the name of the module, requests, and we'll come to what modules are available maybe later. When I press return, it will install not only the request module, but also any modules on which that depends. So if I now try pressing return, you can see it's installing, for example, the URL lib3 module. Now I don't know what that is, but I do know that the request module depends on it. And you can see my list of side packages has grown quite a lot actually. I've got quite a few new ones, but the key one is the request module. So if I now try running my program again a second time, you can see it runs successfully. I don't get anything in the output window. If you're still getting ModuleNotFoundError at this point, don't despair, because I've got a couple of ways to get around this problem coming up. But I've actually previously solved that on my machine, so at the moment mine is working. So having imported a module, I can now use it. So what I'll do now is just show you how you can use the request module to get the contents of a website, just to complete the example. So to do this, I can create a variable called response. And what that will do is take the request module and get the results of a website. I'm going to use HTTPS, and let's go to the BBC website. They can cope with the traffic. So what I can then do is, assuming that that works successfully, I can just display the results of that. So I can put print response.text. And what that will do when I run the program is print out the contents of the BBC website. And there it is in all its glory. Probably very hard to understand because it looks like it's just JavaScript. On the subject of going to websites, we'll be looking at that in a later tutorial in this series called web scraping, and I'll show you how you can use requests in combination with a beautiful soup module to parse the contents of websites. So don't despair too much that seems quite hard to work with at the moment. So that's how you can install an external module. What happens when you still get a module not found error? So what I'm going to do now is to show you how you can solve this problem. I haven't made any changes to this program at all, but when I run it, it says module not found error, no module name requests. And there's two solutions I know of for this, and I'll show you both of them just so you can decide which one is more useful for you. The problem is that it can't find the request module, even though it's there, and that's because it's not in the correct path. Now, normally, Visual Studio Code would manage paths for you once you've set up a virtual environment. If you remember, a virtual environment appears in green to the left of the folder name down there and shows you that you've created a little sandbox in which you can install modules without them affecting any other programs you're writing. And if you haven't watched the tutorial on virtual environments, I suggest you do that now because it's very important. So one solution to this problem is to import the sys module at the top of my program and then append to the existing Python path the place where requests is stored. So to do that, I can take sys.path.append, and then in brackets I can put in the full name of the path. To avoid having to put escape characters before each backslash, I'm going to use the R prefix. So I can type C:, and this will be different on your machine. In my case, it's in the work folder, and then I've got within that a Python folder, and then I've got a tutorial folder, and then within that I've got the lib folder, and within that site packages. For some reason, you need to put a double backslash at the end of it. I've never quite worked that one out. So I'm hoping that will automatically go to this folder and find the request module. So if I run that, it solves the problem and gives me the output of the file. But it's a bit tedious at the top of every single module having to put these two commands in. There must be a better alternative, so that's what we're going to look at now. So I'll comment those out. So the reason this is happening, and it took me a very long time to realize this, is because I'm using the Code Runner program. If I run this program just by pressing Ctrl F5, you can see it gives me in the terminal window the output of my program is working perfectly. It's the Code Runner extension which is actually the problem. But there's a setting I can change to remove the problem. If I go to my settings, and if I go to the bottom, what I'm going to do is just comment back in these lines of code which I'd removed. And what I'll do is add this JSON file to the list of useful files for the video so that you can just copy from that. You can see that I've got a reference to a blog. I've put that in the useful links as well, just in case you find it useful. And what this will do is automatically include the correct Python path. Do I understand it? Honestly, no, but I know it solves the problem. So if I close that down and save the changes, if I now run my program again, it works. And no longer do I have to keep appending a path in the top of my programs. So the last thing I want to do on this tutorial is just show a bit about viewing and listing modules. To list modules, you can go to your terminal window and you can type in Python -m -pip -list. And what that will do is print out a list of all the modules that you've installed. So if I press return, you can see a list. And you can see listed there not just the request module that I installed, but the extra modules which were needed, which the request module was depending on. Now, I think I've slightly overcomplicated this because you can just type pip space list. And providing you're using a virtual environment in Visual Studio Code, you don't need the Python -n before it, and it will still give you the same information. You can also produce a list of modules by using the pip freeze command. And what this will do is you can pipe it, that's the technical word for this, to another file. So what I'm going to do is I've typed that into my clipboard. I'm going to send it to a file called includedmodules.txt. Because that file has a space in, I needed to include the path in double quotation marks. And when I press return, it will create that file. And if you look in my Explorer window, it's just popped up. There it is. And it contains a list of the modules that I've got installed. One other thing you can do is you can actually view the contents of a module by either pressing the F12 key or by going to it. So let me give you two examples of this. I've used request.get there. If I either right-click on that and choose Go to Definition, or just press the F12 key, what that will do is take me to the definition of the get function in the request module. Now, in this occasion, it doesn't take me any further than that. I can't actually see what's happening. It just says that when I come to return the response from that, I just get 3 dots. And that's because this is almost certainly written in another language like C# and then compiled into what's called an executable code. And what that means is I can't get to the contents, which you might not think is that surprising. But if we take something we did earlier, like the today function, I can with this. If I press F12 on this, what it would do is take me to the definition of the function. And it's completely transparent. I can see exactly how it works. My experience of trying to understand these is you will need to be very good at Python in some cases, in particular because it tends to use a lot of things called classes and advanced programming technique. But I find it reassuring that it's such a transparent language, and most of the modules I include are actually written in Python itself. And that pretty much concludes my look at modules. For the rest of all of the tutorials in this series, we'll be happily installing and using modules without any further reference for how to do so.